Hello? All right.
I'm Dave.
What's up, nerds? I know you're nerds because this is the last session of the conference and you're here and not upstairs drinking. You're drinking down here. You're not drinking upstairs.
Priority.
Well, I'm going to reward you nerds with a data-filled discussion. I think we're all going to learn a lot from these two distinguished speakers. Joe Grimm is the owner of Grimm Artisanal Ales, along with his wife, Lauren Grimm, and serves at the head of Grimm's production team as director of brewing. An erstwhile philosophy student, hacker, composer, professional gambler? I won Grimm on a bet. Artist and old-time fiddle player. I love that. That is cool. Joe is an autodidact, which is Brooklyn for self-taught, with no formal training in brewing. With his scrupulous attention to the aesthetics and minutiae of recipe and process, Joe has led his team to Brewery of the Year honors twice here at New York State CBC. In 2021 and 2022, he did share 2022 with Strange Bird. That's what my name's Mika Kretinsky. I'm from Strange Bird in Rochester, New York. Strange Bird 585. 585. All right. Okay, and now we have Laura Burns, PhD. Not that kind of doctor, is the Director of Research and Development at Omega Yeast. After studying stress responses in Saccharomyces cerevisiae for her graduate thesis at Vanderbilt University, she decided the best place to apply this knowledge was in brewing. She worked in production brewing for 5 years as head brewer and Director of Quality Assurance before heading back to the bench at Omega Yeast. Her undeniable curiosity drives her to tackle difficult questions that brewers face daily. Without any further ado, I give you Dr. Burns.
Thank you. I do have a 585 area code. And I also think that it is the right type of doctor. The fun one. Not the one that tells you you need to stop drinking. Anyhow, thank you all for being here today. This is going to be a fun, educational, and, drink a little beer kind of seminar. The best part about this is we've kind of covered this already with you in a 2022 talk on haze, and some of you said that I had to dial it back, but we're just going to do it again. Cover it, and then we're going to get into some even headier stuff, and then make it more fun with the beer. So thanks for having us. The title today is Outlook Hazy or Bright, Yeast Strains to Dial in Haze. So we already had the intro, but happy to be back in New York. Omega's in Chicago. Still cold, still snowing. So what is haze? Haze is, by definition, just turbidity, cloudiness of particles that are obscuring light. So it's analogous to fog or smoke in the air. Like if you're wanting to see the mountains and there's a ton of fog, you're obviously not seeing through the water molecules that are obscuring light. So it's really just particles that are in suspension, colloidal, and keeping you from seeing to the other side, seeing through. So in beer, obviously, I love this picture. These are some of my really good friends back in Chicago. But an Instagram post, one haze fits all. And I think it's just kind of one of those things brewers have had a little bit of a challenge on, is how do we differentiate hazy IPA? What do we do to make this stand out? And I think some of the tips we have here are just going to make it easier to execute haze, and then also make it non-hazy if you want. So haze comes from all of the raw materials. We put it in this Venn diagram because there are contributions that come on their own from the material, but also combine kind of efforts and create other forms of haze with other raw materials. So in malt, we have the protein from the grain itself, and adjuncts are primarily also used to contribute more protein. Polyphenol is coming from the husk. Actually, the majority of polyphenol in your beer is coming from the malt. And then you got another component, beta-glucan, so the oats, flaked wheat. Those are the types of haze you're trying to coax out of those adjuncts. With yeast, we'll say hops first. With hops, you have other phenolic compounds. The distribution of size and composition of these phenolic compounds is going to change by hop variety and hop product. But I think there's a lot of interesting stuff we can dig into there. But for now, all we do really know is that they're phenolic compounds in hops that help contribute. And in yeast, little has been really shown to what yeast are contributing, but what has been in wine and in beer mentioned mostly is the cell wall, or manoproteins, and then another component, glycogen with autolysis, and when yeast are stressed and dead in the beer. So with, different types of haze we talk about in beer, chill haze is one, and then permanent haze is another. But these are ones that have been traditionally studied in lager beer, and may not be really talking about the yeast type of haze. The yeast type of haze is much more of this colloidal haze in the diagram. But with chill haze, these are important kind of when you're focusing on malt and hops for haze. It's the interaction of proteins and polyphenols that is contributing to chill haze. And it occurs at low temps when the beer is cold, but once the beer warms up, it goes away. They're non-covalent interactions, so they're reversible. And then when we're talking about permanent haze, these are much more stable and occurring with covalent interactions. And it's kind of something like chill haze will start to show up in early beer, and later permanent haze develops as interactions become permanent. So it doesn't go away with warming, and you can even force it with repeating cooling and warming, pasteurization and oxidation. And one of the things I didn't know, but I was told with John Mallet actually mentioned it after my talk one time when I was doing a talk with all this information. He said that Hefeweizen producers used to crack the haze, and what that meant is they were pasteurizing it really hard to induce this permanent haze, and that was one way that they were able to produce some more stable haze in a Hefeweizen. So with malt and hops, you've got proteins and polyphenols like we talked about. The proline-rich proteins in malt are primarily what's contributing to this complex, and if you see this diagram, it's just kind of showing that they're like kind of interactions between the polyphenols that are joined by protein. And when you have too much of polyphenol or too much of protein, it doesn't really create a colloidal or stable haze. It's creating less of a stable haze. So when you have haze proteins that are usually they're less than 40 kilodaltons in size, they're smaller proteins, and those are ones that have been really identified in barley and wheat as like the hordenes and the gliadins. And with polyphenols, these are, again, what we're kind of talking about, parenthesine addends, and in hops, again, monomers, dimers, trimers, polymers, epicatechin, catechin, gallocatechin, and actually, you guys probably know about polyphenols when you're using products like Tanol A or Brutan B. Those are different compositions of polyphenols used to either create haze or remove haze. So what kind of haze are we talking about today? It's NEPA level. So not so much at the lager traditional haze of chill haze and permanent haze and the problematic haze. We're talking about haze we really want in the beer. So from drinking water to milk, I just have a scale here, and visibly you can see the NTU standards that are representing those levels of haze. The beer on this image is in the 300, 400 range NTU, and then the clear version of that same beer is in the 40 NTU range. So in orange juice and hazy IPA and milk, you can be in the 200 plus range is what we kind of classify as hazy. And with milk, obviously whole milk is very colloidally stably hazy, and that's in the 4,000 range. When measuring turbidity, we use turbidity meters or nephelometers, and Omega Yeast has a Anton Par Haze QC that we use with our alkalizer. We have lab services, so we had this unit added on to what we had for the equipment. but you can also go with Hock or Optec, or in the brewery you have more inline measurements. So if you run a centrifuge, you have inlet and outlet turbidity measurements, and that's kind of giving you insight into when to trigger discharge. So the crux of all of this work relied on this very simple haze assay that we developed early on when I started at Omega Yeast. It was out of curiosity, mainly for hop creep. We were starting to look at the influence of, different yeast and how problematic hop creep was with certain strains. So we were looking at a bunch of different strains in fermentation when you're adding dry hop at different times. So we started out with our two very popular IPA strains, Brit 5 and West Coast 1. And the dry hop additions were just varied from, no dry hop, or a knockout dry hop, which is the day of knockout in your fermenter pre-pitch, and then day 1 through day 7, and then a double dry hop with an early day 1 addition and a late day 7 addition. And so to get into kind of the talk, we're going to cover haze positive and haze neutral strains. We're going to talk about how dry hopping plays in. We're going to, dry hop timing is the biggest thing we want as a takeaway, but also we're less really understanding of what hop varieties play in, but I'll show some data to show there's variation there, and hop products and dose rate as well. And then the second part of the talk is going to get into what's new. So we found a gene that is in yeast, and it makes hazy yeast haze positive yeast hazy. And we're going to have a fun trial to discuss with Joe at Grimm, where we use this strain without the haze gene and with the haze gene, and really what's the difference. So with dry hop timing and yeast choice, this is just solidify this image in your brain. If you have to have any takeaways from the talk, I think this is one of the most critical and important ones. The first image is our haze positive strain, OYL 011. And the second image is our OYL 004, or our haze neutral strain, West Coast 1. And in this experiment, this is day 14, all fermentation has happened. And we're just taking a visual, but we'll also have NTU measurements of each of these after centrifuging. And if, just by eye, this is the observation we had from start, was wow, this is incredibly obvious that we're getting haze out of certain yeast when we're not out of other yeast. So West Coast 1 was not giving haze throughout all of those dry hop additions, and our Brit 5 was contributing to a lot of haze, specifically with later dry hop additions. If you're early dry hop, you're not getting haze at all. This shows what we see as a clarifying impact, and as soon as you're getting into the later dry hops, you're only accumulating haze. And that's our NTU measurements as promised. This is just showing the output of what levels of haze are in those various flasks. Our knockout dry hop is really down in the pale ale Pilsner level versus getting up into that orange juice territory of 750 NTUs. And then with our haze neutral strain, we weren't producing haze at all. And then Platos are displayed. The only difference we really saw in Plato with dry hop timing was that the late dry hop wasn't really helpful at encouraging hop creep, so it was a little less attenuated. So with dry hopping, if you increase your dry hop dose rate, you're going to increase the amount of haze you see. And I think we all know this. We've seen 4 pounds per barrel is more hazy than half a pound per barrel. But it's also going to be critical at what time you're adding that dry hop. So with the day 4 dry hop, we were getting a pretty appreciable amount of haze with 4 pounds per barrel, but 2 pounds wasn't as hazy. And then you're still getting the decline with day 7 dry hop, but knowing that knockout dry hop in this example, the same, if we added 4 pounds per barrel at knockout, we got no haze. So, and with the haze dependency on the hop variety, really kind of cool, but also pretty confusing. If you can see, the variation between variety is really influencing our haze neutral strain. You're getting some hop additions which result in haze, and others, Triple Pearl or Galaxy or Vic Secret or Cascade, which aren't helping to coax much haze out at all. And these are all day 7 dry hops. The haze positive strain is pretty reliably hazy, but we are getting even differences within that. So some of the hops that really stand out are New Zealand or Australian hops, Southern Hemisphere hops. Often we get this pretty dramatic influence of, haze neutral strains versus haze positive strains. Haze positive strains are through the charts hazy, and haze neutral strains don't benefit much from the haze coming from the hop in that example. Citra, I guess another important thing is there's some varieties that do make some level of haze with haze neutral or haze positive strains. So whatever those varieties are contributing is a little bit different than what the influence is on the yeast and how the yeast is contributing. And then we did want to see between suppliers or differences between product types. How variable is this hop haze? I think overall you're getting haze on hops and the difference between suppliers wasn't super dramatic. Yeah, you're going to get subtle differences, but by lot and by supplier, possibly that could influence the haze you're getting in a recipe. But we see the similar trends, like Mosaic was usually a low haze hop. Citra is usually a high haze hop. And then with the T90 versus cryo, we used equivalent dose rate of 1 pound for cryo versus 2 pounds for T90. And we saw haze occurring, but to get above that 200 level was a little bit more challenging with cryo than it was with T90. And again, that's half the dose rate, so maybe if you were using the same dose rate of cryo, you'd still get haze. Just another illustration of knockout dry hopping not being good for promoting haze. We did this experiment because we saw not only was knockout dry hopping not producing haze, but if you combined it with the late dry hopping, you would expect haze to still happen. Get the haze from the late dry hop, use the early dry hop. We had a bunch of customers who had just started to introduce more early dry hopping, and all of a sudden we're having all issues your yeast is screwed up, what happened? We had to kind of understand a little bit more about what was happening so we could help with the customers, because it wasn't anything that we knew of that had changed in the yeast. It was definitely something that had changed in process. So when working with our brewers, we kind of showed some of these results and said, are you doing knockout dry hop additions? And the obvious kind of connection often was either we were getting really excessive whirlpool additions, which were carrying over hop true particulate into the fermenter, or they were actually adding hops in knockout or day 1, really early in fermentation. So here, if you just see the effect, that small, it was a ½ pound per barrel at knockout. 2 pounds in each case, and then we did a ½ pound, or a ½ pound per barrel, at knockout, and 2 pounds per barrel at day 7 in this case, and we were seeing a massive reduction in haze just with that ½ pound addition at knockout. And that's the visual there, with the left flask is the double dry hop. So we did the kind of pilot example of this on our little homebrew Blickman setup, and we just tried to do a really kind of scale up from the flask to see if this played out. And in this experiment, we did the beer specs and the NTU measurements, and you can see that all under the picture. But on the left is our example where we didn't include the knockout and just did a 2 pound per barrel dry hop, and we were measuring 487 NTUs. This is all barley malt. We're trying to just really exemplify the yeast and dry hop haze that's occurring. And then the other one where we did the ½ pound per barrel of knockout, dropped it down to 32. We don't have centrifuge, we don't have anything fancy, this was just home brewing, and we saw that massive difference. And then when we looked at flavor and attenuation, I think we saw some differences, but it was probably just a little bit slightly more bitter, a little bit slightly more attenuated. It wasn't something that would stand out. The aroma was spot on. So the summary of that work is, with the yeast choice, you can be really influential on whether you get haze or no haze. So if you're wanting hazy, well, kind of makes a lot of sense. Use Brit 5. If you're not wanting hazy, stick with Chico or West Coast 1. And then with dry hop timing, the influence on kind of that early dry hop versus late dry hop, you can influence your result in the finished beer by just shifting hops from early or late dry hop. And then I think the big one is the hop variety and product types. There's like a lot of variability there that we don't understand, but it'll be interesting to learn more about what the hops are contributing. I think the other thing about what we know is like hop haze is a product that exists that is just a CO2 extract from hops, aqueous solution that creates massive haze if you add it to beer. So there are hop components that by themselves can contribute to the haze in beer. So the latest and greatest, we went through like a really fun genetic study and really wanted to get down to what gene in yeast was contributing to haze. We knew it was a phenotype and it was variable among all of the strains in our collection, but could we get down to a specific gene or a mechanism for what the yeast was doing? So if you go to these two articles, one is our Top Crop educational website. From there you'll find a good summary on this and much more practical takeaways. And if you want to dive into the nerdy details, we wrote up a scientific paper that's in review at NYSBC right now, which will kind of detail all the experiments. So in our quest to find the genes, we used a very simple, and one of the reviewers said, eloquent approach to finding the hazy one gene. We just took a classical genetics approach, and we call it back crossing. But the concept is like shuffling two card decks, really. The two genomes of the yeast are just mixed and then we basically go back to, we start with one genome that is hazy and one genome that is not hazy. And every time we mix the non-hazy genome into the hazy genome, we're diluting out all of the genes until eventually we get to be identical to the non-hazy genome, all but one locus, one gene that gives us the phenotype for haze. So yeah, it's called back crossing, but really similarly, you can see an analogy to just shuffling a deck of cards and continually shuffling it into a new deck to get down to just one card, which is that gene. So when we did this, we used a haze neutral strain, which is just a wine strain we knew was a really great strain to back cross to. And then we used our OAL 011, the most hazy strain we knew of at the time. And through here, you can see it's hazy, and this wine strain is not, but every time we back crossed it, we maintain haze. Haze dropped a little bit, but overall, we could maintain this haze phenotype, and by the time we got to the 7th back cross, we were 99% identical to the wine strain, but just carried this one locus, or the haze locus. We did sequencing and compared the genomes, and so like basically if you were looking for the needle in the haystack, the area that shows all the variation is the area that contains the gene. And so we found this area on chromosome 9 near the telomere, the left arm of the telomere, that showed the variation that we were looking for. And this was consistent with only being found in haze-positive isolates. From there, we found, it's just crazy when you look at the genome data. Like, a lot of people are like, I sequenced my yeast strain, and honestly, it's pretty hard to get anything out of the sequence data that reflects a functional phenotype. But what we saw in the sequencing data was there was a ton of coverage over this region on chromosome 9 of all of the reads that were coming from the sequencing data. And what that indicated to us is that this was probably a region that had a lot of repeats and was just stacking up on itself. And what we found was that the hazy version of hazy 1, or the haze gene, just had a bunch of repeat expansions in part of the gene that led to this result of haze. And so we have all of our strains sequenced at Omega Yeast. So we went and looked at all of the different lengths of this region and all of the strains that we have. And from the blue ones here, those are haze positive isolates. Red ones are all that we know that are haze neutral. And if you look here too, the lager strains kind of line all up there too, with like basically a shorter length of the gene. And if you get into this range of like 4,000, that's what we're seeing with some of the haze positive isolates. And that was consistent with our haze phenotype. So, and there's a lot of variation here, but the one really the awesome thing that we saw is the strains that we didn't know were hazy. We actually went and tested, okay, are these hazy strains based on what we found in the data? And it turned out they were some of our haziest strains. So our 009, our 077 Australia Ale strain, and our 001 were all very hazy and consistently had this expansion. So what did we do next? Well, we engineered them, so we got rid of the haze gene. We just deleted that gene in strains that were hazy. And this is another pilot example like you saw with knockout dry hop timing. We ran a beer trial and found that the strains with the intact hazy gene made hazy beer, and when we deleted the hazy gene, we lost the haze phenotype. And here we are with the same kind of NTU measurements, like with the normal version of the gene, and then when we deleted the gene, we saw that big reduction in haze. So here comes Grimm. I was just on Master Brewers, I guess the, what is it, Brewmaster, Ask the Brewmaster thread. Yeah. And I caught wind of like kind of a thread Joe had started on haze and how the strain they had in the brewery just seemed to have lost the haze they had expected over their serial repitching. And they were on a quest to kind of build a house strain and differentiate their strain from others, but in the process, lost haze. So we took their strain and ran it through the haze assay that we had. This is where we deleted the hazy 1 gene, but we picked a bunch of other suppliers' versions of Brit 5 that we used in our studies and compared it, and they were all hazy. And all of a sudden, Grimm's strain is not. So we thought it was obvious that it had lost its haze phenotype, and then we sequenced it, and we found that the version of the long gene that's in our OIL-011 strain was not, and it completely collapsed and was not found in the Grimm strain. So it had lost the expansion in the gene, or the version of the gene with the expansion. So I'm gonna let Joe take it from here.
Sure. Have you all had a chance to scan the sensory bit? Maybe should I show that little scanner thing just in case anybody needs to go back to that? All the way back here. So scan that so that you can do the sensory. What we have in front of you is two versions of a beer made from the same wort. Everybody got it? I see, still see some thumbs. That's good. Take your time. We'll forget. All right. So what you have is two versions of the same beer. It's produced from the same wort, and we side streamed it into two identically shaped tanks. They're two 7-barrel tanks with the exact same geometry. Same pitch rate, and produced from the same wort at the same oxygenation, and really everything the same. But the beer number 1 is fermented with British 5, aka London 3, aka Juice, aka, you name it. And one of the other beer is it's the hazy 1 gene deleted version of the same strain. And what we wanted to find out is, can we taste a difference? Is there any sensory difference between when the haze is present and absent? And so that's why we wanted you to not look. Let's see. Okay, so this particular beer, pretty simple. It's just 88% pills, 12% wheat, and we put 1.2 pounds per barrel of Simcoe in the whirlpool, and just a 1.5 pound per barrel dry hop with Eldorado. For this particular beer, we put the dry hop in at 4 Plato. The beer was just about done. And then we saw it sort of tick down another ½ degree Plato after that, and they ended at the same point. This was a Gen 0 pitch for both, so the fermentation was a little slower than we usually see, but otherwise basically identical. Yeah. And then this is our own triangle test that we did at Grimm. And what we found was, we were trying to find out whether our own staff could pick out the difference between the two. And we found that in the triangle test, only 2 out of 7 people correctly identified the sample. Those did happen to be our 2 most experienced tasters. But it's also a number that is consistent with blind chance. So, let's see. This is what we saw when we had people actually run through their sensory. People actually found that one of the beers had just a little bit more than the other, but they were pretty close. I mean, you couldn't really ask for closer than that, I suppose, given that they were actually literally 2 tanks, different amounts of volatiles gassed off, and 2 different canning runs, etc. It's hard to get exactly the same. And so, Laura was asking me to sort of give some brewer perspective, and I was like, well, how do I put my thoughts together on this? What I think is that there are many kinds of haze that we see in New England IPA, and some of them are obviously bad. Yeast and suspension is that's an issue in a lot of these beers, and fine hop sediment is an even worse issue. That's going to bring that really, really gnarly hop burn, very intense bitterness. But there are 2 kinds of haze that are, arguably good, or they're, good depending on your intention. And, you were saying yesterday, we were talking about whether haze is a flavor. And was it the guy at Cloudburst who says, hey, haze is not a flavor?
Yeah, they have a bumper sticker, it's cute.
So is haze a flavor? And I was thinking about this, and I was like, well, yes and no. Okay, so we've got, what I'm pulling apart is 2 different varieties of haze that are found in this particular family of beers. The type A haze is the hop and grain-based polyphenols. My opinion is that it's less colloidally stable, and that you can taste it. It's going to have mostly a mouthfeel thing, and the thing to remember is that polyphenols are tannins. So the kind of tannins we get from dry hopping are not going to be exactly the same as what we see in wine, but that gives you a little bit of a sense. It's a textural experience, and it can give an impression of hoppiness, of intensity, but also maybe it's not so soft. So, your mileage may vary. On the other hand, we've got what I'm calling that type A haze. What I'm calling type B haze is the stuff that Laura and the team have really discovered. And this is really not in any of the brewing literature. It's probably only, at least judging from our sensory results, probably only has a visual impact. And has really no drawbacks. So it's a nice thing to have. It makes the beer look cool. Another thing to notice is, I don't know if you spent very much time on this slide, but there was a slide that Laura showed where she sort of listed some of the strains that are not hazy, and one of them is Conan. So that's something to think about. Anyone who's using that particular strain, the kind of haze that they're getting is going to be mostly the type A haze. And that might, the Alchemist beers have a very particular hop profile that, it's great. That's a little clue to what is the character that particular kind of haze gives. Okay, so just pulling these 2 apart, anytime you're reading any historical brewing literature about haze, it's always what I'm calling type A haze. And I think actually a lot of breweries ended up looking at some of these beers early on that were coming out of places like Hill Farmstead, and they're like, wow, look at that beer. That looks hazy and it tastes great. How do I do that? And then they started adding more and more wheat and oats, right? Which does produce haze, but it isn't the same thing. If you're like reading the brewing literature and trying to create more haze, it's gonna lead you to type A. So this is the kind of stuff you find in Hefeweizen and Wit. It's not as colloidally stable. It will drop out of the beer faster, and that's what we were seeing. We had some beers that were hazy for 2 weeks, and then they'd drop clear. It's very frustrating for me. And that's why I was, desperately typing on MBAA. I know of one very big brewer that is making hazy IPAs that are in very wide distribution, that are very stable with Chico, and they're making a type A haze, pasteurizing it. So it's the same thing that wheat beer producers do. If it gets a little heat cycle, you can make that type A haze very stable. That's a tool that you may or may not have. We don't have it. And remember, polyphenols are tannins. So when you think about what is the impact of that, it ups the level of tannin in the beer, which may be bad or may be good depending on how it's balanced. Type B haze is really new. I asked Laura what she thought about I was like, okay, but when I was first making these beers 10 years ago, the question that was on everybody's minds is like, what is the haze? Everybody was like, these beers are disgusting. They're poorly made beers. You didn't finish your beer. And then, people like me were just out there saying, no, this isn't that. It's something else. I can't tell you what it is. But there's not yeast in suspension in my beer. But we still don't know. What we do know is that this is a kind of haze that is produced when some strains of yeast come into contact with dry hops late in their fermentation. I was asking Laura, what is it literally? And she's like, well, we don't know what are the biophysical properties of this haze. So that's going to be a matter for further study, I guess. In my imagination, because I have like a caveman brain, I imagine that the yeasts are there in the beer, and I'm throwing dry hops in the tank, and then the yeast see the dry hops, and they're like, ah! And they like excrete a bunch of milky stuff into the beer. But I don't think that's necessarily, that may not be what is literally happening. But it wait, it's just I don't know whether they're excreting the white haze or whether they're releasing it from a precursor that was already there. We don't know why it's happening. Is it stressing them? Are they having a negative reaction to it? It's unknown. Oh God. And as far as we can tell, it doesn't deflect the flavor of the beer. But what it does do is it tells a story about what is in that glass, right? It's a pretty reliable visual indicator of a high hop rate and of a particular kind of yeast strain. So if somebody sees a beer that looks like that, they know something about what it's going to taste like. Okay, so a couple of just experiments, not even really experiments, just going back through our history of beers that we've made that did things with these. So this is a beer that it was like a little bit polarizing around the brewery. We made it with our Hefeweizen wort. It's just our Grimm Weisse, and then we fermented it with hazy IPA yeast strain and dry hopped it like it was an IPA. And when we drank this beer, we discovered that the character was just really different than what we usually get in our dry hopped beers. It was a more assertively tannic mouthfeel, and I would describe it as like a bracing, hop intensity with bitterness coming from the dry hop that we didn't put in an IBU. And this is the opposite. So this is a beer that we made with 100% base malt. And in this beer, it was just, soft and fruity. So, okay, so now that you know some of the stuff that Laura was describing earlier, how do we put it to work? What if I want to make a West Coast IPA? Oh, an aside, I don't know why our yeast lost its ability to create haze over those generations, but if I had to guess, I would say it's because we were doing this. We were making a bunch of clear or clear-ish IPAs with the Hazy yeast strain. The way we were doing it is we were using a day 0 dry hop with T90 on basically a West Coast grist. And then we were, we were just capturing that yeast and repitching it. So we were starting to get interference from hops in our yeast cell line, if that makes sense. We were harvesting beer that had fermented in the presence of hops. And this is an example of what we did with that. Classic Rewind, or all the Rewind series up until about 6 months ago, were made with our house yeast, but we were making them into a West Coast style. And so we did that with a day 0 dry hop, and we would soft crash the beer and then dry hop cool for short periods of time. And we were using cryo and choosing our varieties for late dry hopping because we didn't want them to contribute haze. So you can see it comes out pretty clear if you follow that process. One of these beers, Mosaic Rewind, got a silver medal here in American IPA. So this is something that you could do. Just don't repitch and then expect to use that yeast again for hazy. All right, so what if I want to focus on softness and fruit character? In that case, you might want to consider bringing your wheat and oats down. The wheat and oats is going to bring type A haze, which has a more aggressively hoppy character, in my opinion. And in that case, you might want to add your dry hops just before fermentation ends so that you get a little bit of that beta-glucosidase action, which releases extra linalool and geraniol, and gives that very soft fruit character, that's what we used for the test beer that you're drinking today. And what if I want to, on the other hand, focus on volatiles? So volatiles are going to include, some of your onion garlic, but also some tropical. They might be a little bit more polarizing, but also more intense type of aroma. For that, you don't want to have any aromatic scrubbing because they just come out of the beer so fast and so easy. So you have to add them when the beer is completely done. Maybe we should look at the sensory results. Do you want to drive, Laura?
Sure.
Yeah.
I feel like this requires my personal hotspot.
Never rely on Wi-Fi. Just think I can escape. Ooh, here you go, guys. The best part for me is always digging through our fun little off-flavor stuff, but usually the only point of putting an off-flavor in there is so that people indicate whether they were picking up a difference in the beer that was due to an off-flavor, not actually due to the actual aroma they're experiencing. And then I auto-generated a couple of, it looks almost identical to yours. Oh wait, actually, no, sample A. What was sample A?
Sample A is normal.
So we got Hazy in this case, our OIL 011 strain, coming through with some fruitier, sweeter, and hoppier aromatics. And then sample B was coming in a little bit muted. And honestly, it's really difficult to do this. Sometimes order in sensory is just more influential than the actual differences in the beers. Also, packaged product is really difficult to keep consistent. So I feel like what we see here maybe kind of probably order in sensory. We're picking up more fruity on A because we tasted it first. But then we also had people where, I don't know if you looked at the lip of the can, but you guys actually got the correct answer. The hazier sample was sample A. A lot of you said there was no difference. That's a big 9% of the people tasting said we couldn't say there was a difference in the two. And then within the preference, people preferred sample B, even though y'all rated, sample A, excuse me. And that, again, that might be order bias, but either you like hazy beer a lot, or you're just preferring what you perceived as a higher aroma intensity and a little bit more impact from those samples. I'll dig into this a little bit more if anyone has questions, but the fun one for me to always look at is there's always with California when we did this, there was this 50-50 split, but every time somebody said a sample was hazy, they said they liked the other one. Yeah. But, there's always more to unpack with sensory than just, you can't really just rely on a couple stats. But all in all, I would say, from the blind sensory. Yes, that's a great idea. Yeah. And when we have done a bunch of these trials side by side at Omega, where we're blinded, we actually keep the cups black just like Grimm did, and we put black caps on them too, and make it so people have to drink through a little crack. Because I don't even trust myself. The first time I did it, I literally put a blindfold on because I'm a cheater. But I really do convincingly in our side by sides, we've always had a really difficult time determining a difference. And I would say if anyone does, it's always our best taster. But I think those best tasters can recognize subtle differences in attenuation, subtle differences in off flavors. They're not picking up overall flavor impacts that haze contributes. It's the nuance that they're picking up on. And we ran a bunch of these samples. If you guys remember, and actually this was pretty cool research, but Hopsteiner had the hidden secrets of the NEPA that they put out a long time ago. 2016 was when we started this game. But their research was really just looking at finished beer and the difference between solubility and certain hop compounds. So they saw non-polar hop compounds were more prevalent in hazy samples. A lot of that was process. And we have not changed process here. So when we went to send the samples back to Hopsteiner for HPLC, how are the beta acids? What's the caryophyllene? What's the, xanthahumol? All of them were lining up. So it wasn't that the compounds they were identifying as changing in NEPAs were changing in the samples we sent them.
Okay, so I probably should have had a higher hop rate than 1.5 pounds per barrel in the dry house, just to exaggerate it more, but it's pretty clear.
It's pretty clear. That's the worst, is we can't avoid the word clear. Yeah. Milky is definitely coming out in that second example.
There's some type A haze in both samples, but there's only type B haze in.
Yeah, and honestly, a lot of the time too, if you're wanting to really clarify a beer, you need to rely on other things like I don't know, Clarex or biopining or, you know, even the knockout dry hopping has been a useful tool, but, you know, this is without any of that. So you're gonna expect some level of haze just by recipe design, you know? You got a really great amount of aroma in there, like, and the hop varieties are gonna influence haze too, so. Also, thank you so much, these are wonderful beers.
If people do want to play with the Grimm 300 and like a clear version of it, can they get that?
Yeah, we got it banked. Yep. It's in the R&D collection, but we did keep it. We kept it because we would, you know, if we had to go back to sequence or do any comparisons again, we could always go back to it. And then we also have the strain that Joe used, this non-hazy version of London 3. We actually have it in R&D form right now, but we'll be launching a couple of strains that you can use to make non-hazy beer, or strains that you can use to make hazy beer. So we're flipping the tables. So if you want to make hazy beer or non-hazy beer, you're going to have more variety in the strain you use versus what we are stuck with kind of right now. And what I experienced in the brewery too, I ran hazies with Conan and Brit 5 and couldn't take Conan past Gen 3 because I couldn't reliably expect haze out of it, or stable haze. And I was contract brewing at the time, somebody was like, this is not hazy. I'm like, what are you talking about? Of course it was. It was like three weeks later when they received the beer in the cans, and I was like, what the heck happened? So this is something that, you know, with that type of a really struggle point for brewers, we want to be able to provide something that's more reliable. So this is just kind of a summary of different strategies and approaches to making different styles, using haze neutral, haze positive, late dry hopping, early dry hopping, but you guys can really play around with those insights that we have and know what strains work best and what hopping protocols you kind of can follow to develop the haze you're looking for. And this is kind of coming to we had a really great example of like what yeast are doing already. But we have, so the hazy 1 gene is actually a manoprotein, so it is part of the cell wall of the yeast. And when we have done experiments where we remove the yeast completely, it seems like this manoprotein is already in the beer because you can dry hop the beer without yeast around and you're still getting haze. So somehow this hazy 1 in the late fermentation is making it into the beer. And when you're triggering it with a dry hop, it's producing this colloid or this stable haze, milky kind of look of kind of orange juice. So we don't really know why certain strains have developed their haze phenotype of haze positive or use this kind of expansion in the gene to create haze, but we think it might have been linked to top cropping. So there are certain genes we know of, the flow genes, that have been expanded and exploited in domesticated strains of our industrial strains to help us collect them at the bottom of the cone. But a lot of our haze positive strains were traditionally top cropped. So maybe by selecting for flocculent strains, we've gotten haze neutral strains. Selecting for top cropped strains, we've been able to exploit this phenotype of haze. So like Kolsch strains, Hefeweizen strains, this English strain, they were all traditionally top crop strains and have this expansion in the gene and also have this hazy phenotype. So and all the but one lager strains that we have, which have been always traditionally bottom cropped, do not have that phenotype. So it might not be a perfect correlation, but it is something that we think might be playing into that phenotype. And that is that. Thank you guys. We are good on, it is 5 o'clock, but questions, come on, you can ask anything.
Yeah, super quick. One for each of you.
Sure.
Joe, how many generations were you fishing before you started to see that drop out of haze?
We started noticing it gradually, and we were probably 250 generations in or something. So I think it's okay. I think if you top crop, it's okay to take this really far.
Yeah, sure.
Yeah.
I see. Yeah, that's okay. That's all good. I like the stance. And how does that if you use it? What do you actually do
Exactly, yeah. At the end of fermentation, we take the beer, we centrifuge it to remove the yeast in suspension at a low speed, which is kind of comparable to what you guys be doing in the brewery. And then we put it through the nephelometer, which is just reading light scattering at a degree of 25, like the light shines onto the sample at 25 degrees or at 90 degrees. And the difference between those angles correlates to small or large particles, and that is what we use to calculate the final NTU. Yep.
So, what you're saying is that the particulate is not falling out of solution.
No, I mean, it will forever, like, it's not going to be the sludge at the bottom of the keg, but it will. I mean, I have a sample from when we did this with Georgetown Brewing in Seattle, and it's sitting in my fridge because I just want to see, like, how much will it actually settle out over time. And it's in a clear glass too, so in a bottle. So I can see the top layer is starting to form some level of, like, this just thin layer of clarity, but overall this is very stable and colloidal.
It's much, much more stable than the Type A. The Type A will fall out of the beer.
So Hazy B is not falling out, or it is slowly.
Haze B, the problem with that is I kind of referenced like a Goldilocks scenario. So it can be stable over time, but when there's a scenario where there's too much protein or too much polyphenol, it results in instability. And so it'll be like the fish food flake, which is my favorite. Maplewood describes it as fish food.
And there's some beloved beers that have a fish food flake haze in them.
Which you drink from the can. See? We didn't want you guys to know. It's all in there.
I was wondering at the Day Zero hop you tried, P90 versus top.
We have not. Joe, do you know?
I just have an opinion about that, which is that you want to trigger the risk. If you want to make the beer clear, you want to trigger that haze on the first day.
Echo.
And so you want to use something that's going to produce the haze at that point, right? So that's why when we did it, we used T90 at knockout.
You do really? Just pretend the room is like 10,000 people.
And then we would use cryo late, because cryo is not going to create as much haze, right? So for us, our formula for making a West Coast with the British yeast is we knock out at a relatively cool temperature to turn the esters down. We add T90 at the start of fermentation, and then cryo is the last thing. You want to keep that final dry hop, to varieties that aren't going to create as much haze.
Any one of you. First count.
Do you let when you do Day Zero knockout for clarity, do you let it settle out and drop down before you pitch?
We would just ferment in the presence of hops. I would have to look it up. It's probably like, maybe it was excessive, but it was like a pound per barrel.
One of the good things, honestly, I say late dry hopping for haze, but if you do those early or mid-fermentation dry hops while yeast is very active, it can push the creep much quicker. So you're not going to deal with the hang-up of like that ledge of waiting for that beer to hit terminal, and also diacetyl clearance will help. It'll clear faster. So, there's obviously a lot of benefits to different approaches, so it's not always a one-fix-all scenario, but choose your battle.
I have a question. So are we naming brewing-specific genes using the International Protein Nomenclature Convention now?
Yeah, so with genes in yeast, when they don't have an identified, or they have putative orths or genes that don't have identified function, often it's because we study lab strains and who the heck would have made beer with it, and made a hazy beer. So when they aren't known functions of the gene, they just have a ORF name. So YOL, what was it? It was actually YOL169C.
Okay. So it wasn't in the flow family. It wasn't even in.
No, yeah. And even honestly, the lab strain, if you try to annotate the flow genes, like what you find in brewing strains, is very different. the position of the gene, the chromosome, the expansion, like this telomeric region in brewing strains is just a mess of recombination. So this is part of that, expressing in a very different way, but we as brewers domesticate these to provide us with the phenotype or that change that we've selected for.
I think we've made it.
Yeah, it is pretty cool that we have access to centuries of, these strains that have been used like Grimm did, where they went 300 generations and found a different result. But
Can you talk about the mechanism of yeast flocculating up or down, like how that works?
yeah, there's a gene that's really similar to this Hazy 1 gene that when it had an expansion and repeats, actually created buoyancy. So it was almost like instead of dropping and collecting in clumps, it was allowing CO2 to kind of carry it up to the top of the fermentation. So
Morphological difference?
it's really cell surface hydrophobicity and the composition of that surface of the yeast cell. When there are flocculins on the surface, they basically have like kind of little reachers that lectins, proteins, and carbohydrates just clamp on together. But this other cell wall composition is promoting buoyancy.
And then the flocculation, then bottom, like things that drop, they also come together, but they fall to the bottom.
Exactly, yeah.
So, yeah.
Yeah, and I mean, you guys know, most of your Brit 5 probably ends up in the drain. The way that the strain gets up into the top of the tank is certainly for krausen, for cropping from the top of the fermenter. So I do, and the Hefeweizen and Kohl strains similarly. But yeah, we don't really have much more than that, honestly. And the lab-based assays I did for buoyancy are pretty they're flawed, because even when I delete the Hazy gene, I don't see a change in that buoyancy in the lab assay. So not something I've been able to really crack.
So on type B, I saw 2, 4, 7 day dry hop addition. Is there an optimal addition timing?
I always just say terminal. I would prefer you get your yeast and reharvest and then dry hop, and then we won't have carryover effects from previous batches. Like hops in contact with yeast will change haze. We don't know how.
Also, it's really a matter of what's your strategy for dealing with hop creep? Do you want to go ahead and get it in there and then finish out? Or do you want to try to finish the beer and then get it in and then somehow skip the hop creep package, That might play into your decision.
Yeah, but if you can, and you have kind of like basically your yeast farm is running, and you can run off this side batch that you can dry hop whenever you want. You're never going to have to harvest from it. Don't worry about it. Use your strategy to make that beer style the way you want it to, come out. But the only real hesitation would be to reuse dry hop, like yeast that has been dry hopped, because you don't know how that'll impact the next batch. And honestly, with Conan, when I was using it, Gen 3, I don't know if maybe that strain just quickly mutates away from a haze, and it just doesn't last long in the strain, and it's just more susceptible to the loss of that trait. Or if at the time I wasn't really keeping track of which batches were T90 or cryo. So I think there's definite things you just want to pay attention to and really kind of keep in records to give yourself more indicators of what's happening.
Some advice I got from a big brewer that I trust, who makes hazy beer with a neutral strain, was to keep hops away from the haze, or away from the yeast if you're repitching it. And I think that's a piece of it. They found that if they were harvesting from something that had been in contact with hops, they would lose the haze that they did have.
Yeah, and as another side, our Chico or West Coast strain has a haze phenotype. It actually produces haze. We just don't call it hazy because it's not above 200 NTUs. Pale Ale has a level of haze. IVAs have a level of haze, especially when you're using those late dry hops. So even with Chico, you're going to experience a level of haze, and you can coax it out of that strain. But again, it might be problematic if you're running like West Coast and you want to reduce haze.
Are you seeing a difference in clarity as sort of on the opposite side of things, if you are doing the 0-day dry hop, as the generations continue, is the clarity better more quickly as the generations continue, or is the clarity pretty much the same from that Gen 0 onward?
I can't really say with any certainty, but I have somewhat of a suspicion that our practice during this period, when we were doing a lot of day 0 dry hopping, was why the yeast changed in its performance overall.
They domesticated away.
Can't prove it.
Yeah. It is in our trials too. We've only really done a one and done kind of example, so I don't have any repitching data on that. But based on yeast have this form of memory that can be both just protein memory, and you're only getting so many generations out of your yeast in a given brew cycle. So I would assume that would carry over into the next batch, even just based on not a genetic change, just the memory of the event.
Have you tried any repitches for like London 5 and everything? Where have you seen the haze go down at all in that strain, or was it just that photo you were looking at?
I mean, we don't. I mean, again, with we don't have many customers going beyond 10, and I think if you're taking one of these haze positive strains out, it's going to take more of an influence on selection. What are you selecting for? Like if you introduce those early dry hops, or chance, and somehow one of those mutations arises and takes over your population. But the work that has been done on serial repitching has really just been done in Chico, and there are events that occur between 0 and 10 generations that can, get rid of half a chromosome or make another chromosome appear. So,
And
yeah.
Laura, if,
Yeah.
Like pre-harvest, pre-dry hop, kind of good practices, but it seems like it might just be a thing too, right? Like the mutation to go in that strain. Because I can't believe Joe all top crop for 300 strains, 300 generations.
yeah, that's just how we get yeast in our brewery.
Yeah, we're at it.
Mm-hmm. Well, you know what? You go into this and it's like straight up luck when you come up with this type of an observation, because how many, we have decades of research in yeast. It's just not been applied to beer. So, yeah.
The Saccharomyces cerevisiae, our brewer's yeast, is the most studied organism on the planet. It's
First
what-
genome sequence,
It was the
eukaryotic.
analog for testing anything. So yeah, we are fortunate because we get to access that data and see where we've gotten to this point.
Yeah, and when you get to, an example of a lab strain, which everybody wants to use for consistency, but then you look at the diversity in nature or in domesticated industries, because we're not the only industry that uses Saccharomyces cerevisiae, those traits really evolve. So it's really interesting to see not just what's in the research, but also what's in the world. And our brewing industry is definitely making things different, changing it up.
I have one question for you, Laura. So my impression is that we can see differences in performance in yeast from an epigenetic, change that happens much earlier than an actual genetic change may happen. Do you think that that's the case, and could that be involved in some of these lower repitch count shifts?
Definitely. I mean, I studied epigenetics in graduate school, so my graduate work was on how yeast respond to stress and how gene transcription can be affected by nuclear structure, epigenetic changes, and kind of coupling of all of the events to response.
So just because we don't find a mutation doesn't mean that we're not seeing.
Yeah, you can kind of, for an example, you can bring a normal strain up to a temperature that they would die, but if you brought them up to a temperature where they barely survive and then expose them to the temperature where they would die, they live. So they're conditioned in their response, and they know they can basically express some sort of a program to keep them from dying the next time they see that stress. And all we do is stress out yeast. So we are constantly affecting their expression profile, whether we're exposing to different sugar sources, whether we're changing the environment and temperature, like we're always influencing the way they express their genes, and that definitely, I mean, y'all do a good job, but like when yeast is harvested from a tank that isn't performing, just dump it. You're not going to want to carry that on because you really don't know how that yeast has been kind of triggered into its response of stress.
All right. That sounds like my last relationship.
Thanks. That was great. This was great. Thank you so much. Laura, Greg.